The general strategy for solving a cubic equation is to reduce it to a quadratic and then solve the quadratic by the usual means, either by factorizing or using the formula. A cubic equation has the form ax cubed plus bx squared plus cx plus d equals 0. It must have a term in x cubed or it wouldn't be a cubic, but any or all of b, c and d can be 0. So for instance, x cubed minus 6x squared plus 11x minus 6 equals 0 is a cubic. So is 4x cubed plus 57 equals 0. So is x cubed plus 9x equals 0. Just as a quadratic equation may have 2 real roots, so a cubic equation possibly has 3. But unlike a quadratic equation, which may have no real solution, a cubic equation always has at least 1 real root. I'll explain why later. If a cubic does have 3 roots, 2 or even all 3 of them may be repeated. This gives us 4 possibilities. The equation x cubed minus 6x squared plus 11x minus 6 equals 0 factorizes to x minus 1 times x minus 2 times x minus 3 equals 0. This equation has 3 real roots, all different. The solutions x equals 1, x equals 2, or x equals 3. I'd like to show you the graph of the curve y equals x cubed minus 6x squared plus 11x minus 6. I'm not very good at drawing freehand graphs, so here's one I prepared earlier. Notice that it starts low down to the left, because as x gets large and negative, so does x cubed, and it finishes high to the right, because as x gets large and positive, so does x cubed. And the curve crosses the x-axis 3 times, once where x equals 1, once where x equals 2, and once where x equals 3. This gives us our 3 separate solutions. The equation x cubed minus 5x squared plus 8x minus 4 equals 0 factorizes to x minus 1 times x minus 2 all squared, and that is equal to 0. In this case we do have 3 roots, but 2 of them are the same. We have x minus 2 squared, so we only actually have 2 solutions. Again, I'll show you the graph of y equals x cubed minus 5x squared plus 8x minus 4 equals 0. Again, the curve starts low to the left and goes high to the right. It crosses the x-axis once and then just touches it. So we have our 2 roots, x equals 1 and x equals 2. And it touches at the repeated root, x equals 2. The equation x cubed minus 3x squared plus 3x minus 1 equals 0. The left-hand side factorizes to x minus 1, all cubed, equals 0. So although there are 3 factors, they're all the same, and we only have a single solution, x equals 1. The corresponding curve is y equals x cubed minus 3x squared plus 3x minus 1. And it looks like this. As with all the cubics I've shown you so far, it starts low down on the left and goes high up to the right. Notice that the curve does cross the x-axis at the point x equals 1, but it is also a x-axis is a tangent to the curve at this point. indicating the 3 repeated roots. Now look at the equation x cubed plus x squared plus x minus 3 equals 0. This expression factorizes to x minus 1, x squared plus 2x plus 3. So we can put this equal to 0. The quadratic x squared plus 2x plus 3 equals 0 has no real solutions. So the only solution to the cubic equation is to put x minus 1 equal to 0, giving the single real solution x equals 1. The graph y equals x cubed plus x squared plus x minus 3 looks like this. And you can see that it only crosses the x-axis in one place. From the graphs that I've shown you, you can see why a cubic equation always has at least one real root. The graph either starts large negative and finishes large positive if the coefficient of x cubed is positive, or it will start large positive and finish down here large negative if the coefficient of x cubed is negative. The graph of a cubic must cross the x-axis, giving you one real root. So any problem you get that involves solving a cubic equation will have a real solution. Now let's move on to how we solve cubics. Like a quadratic, a cubic should always be rearranged into the form ax cubed plus bx squared plus cx plus d equals 0. The equation x squared plus 4x minus 1 equals 6 over x is a cubic, but I wouldn't like to try and solve it in this particular form. We need to multiply through by x, giving us x cubed plus 4x squared minus x equals 6. And then we subtract 6 from both sides, giving us x cubed plus 4x squared minus x minus 6 equals 0. When solving cubics, it helps if you know or think you know one root to start with. For instance, take the equation x cubed minus 5x squared minus 2x plus 24 equals 0, given that x equals minus 2 is a solution. There is a theorem called the factor theorem, which I'm not going to attempt to prove here, that says that if x equals minus 2 is a solution of this equation, then x plus 2 is a factor of this whole expression. This means that x cubed minus 5x squared minus 2x plus 24 is equal to x plus 2 times some quadratic, which we'll call x squared plus ax plus b. And then all that is equal to 0. So our task now is to find a and b, and we do this by a process called synthetic division. This involves looking at the coefficients of the original expression. So for instance, the coefficient of x cubed is 1, the coefficient of x squared is minus 5, the coefficient of x is minus 2, and the constant is 24. And we just write in that we're synthetically dividing by minus 2. I leave a line and then bring the 1 down. 1 times minus 2 is minus 2. Minus 5 plus minus 2 is minus 7. Minus 7 times minus 2 is 14. 14 plus minus 2 is 12. 12 times minus 2 is minus 24. And 24 plus minus 24 is 0. The 0 tells us that x plus 2 is indeed a factor, and the numbers we have here give us the coefficients of the quadratic. A is equal to minus 7 and b is equal to 12. So the quadratic that we're looking for is x squared minus 7x plus 12. And synthetic division is explained fully in the accompanying notes. So we've reduced our cubic to x plus 2 times x squared minus 7x plus 12 equals 0. X squared minus 7x plus 12 can be factorized into x minus 3 times x minus 4. So we have x plus 2 times x minus 3 times x minus 4 equals 0, giving us x equals minus 2, 3, or 4. If you don't know a root, it's always worth trying a few simple values. Let's solve x cubed minus 7x minus 6 equals 0. The simplest value to try is 1. 1 minus 7 minus 6 is minus 12, so that doesn't work. Let's try minus 1. Minus 1 cubed is minus 1 plus 7 minus 6 is 0. So minus 1 is a root, which means that x plus 1 is a factor. If minus 1 is a root, we can synthetically divide through this expression by minus 1. Coefficient of x cubed is 1. The coefficient of x squared is 0. There's no term in x squared. The coefficient of x is minus 7, and the constant is minus 6. And we're synthetically dividing by minus 1. I bring the 1 down. 1 times minus 1 is minus 1. Minus 1 and 0 is minus 1. Minus 1 times minus 1 is 1. Minus 7 plus 1 is minus 6. Minus 6 times minus 1 is 6. Minus 6 add 6 is 0. These numbers give us the coefficients of the quadratic equation, and we have x squared minus x minus 6 equals 0. And we now need to solve this equation. So we have x plus 1 times x squared minus x minus 6 equal to 0. X squared minus x minus 6 factorizes to x minus 3, x plus 2. So we have x plus 1 times x minus 3 times x plus 2 equals 0. And the three solutions to the cubic equation are x equals minus 2, minus 1, or 3. Sometimes you may be able to spot a factor. In the equation x cubed minus 4x squared minus 9x plus 36 equals 0, the coefficient of x squared is minus 4 times the coefficient of x cubed, and the constant is minus 4 times the coefficient of x. This means that we're going to be able to take out x minus 4 as a factor from those two terms and those two terms. Those two terms are x squared times x minus 4. X squared times x is x cubed. X squared times minus 4 is minus 4x squared. those two terms are minus 9 times x minus 4. Minus 9 times x is minus 9x, and minus 9 times minus 4 is plus 36, and all that is equal to 0. And we can now factorize again because we have a common factor, x minus 4. So we have x squared minus 9 times x minus 4 equals 0. X squared minus 9 is the difference of two squares. So we can write that in as x plus 3 times x minus 3 times x minus 4 equals 0, giving us solutions x equals minus 3, 3, or 4. You may have noticed that in each example that we've done, every root is a factor of the constant term in the original equation. For instance, 3 and 4 both divide into 36. As long as the coefficient of x cubed is 1, this must be the case, because the constant is simply the product of the roots. 3 times 3 times 4 is equal to 36. This gives us another possible approach. Consider the equation x cubed minus 6x squared minus 6x minus 7 equals 0. Now it's possible for every solution to be irrational, but if there is a rational solution, then because the coefficient of x cubed is 1, it's going to be an integer, and it's going to be a factor of 7. This only leaves us with 4 possibilities: 1, minus 1, 7, and minus 7. So we can try each of them in turn. You can see fairly quickly that 1 and minus 1 don't work. So let's try 7. Rather than substituting 7 into this expression and having to work out 7 cubed and so on, what I'm going to do is synthetically divide by 7. Because if 7 is a root, I'll end up with a 0. And what's more, the division will give me the quadratic that I'm looking for. So let's synthetically divide this expression by 7. The coefficient of x cubed is 1. The coefficient of x squared is minus 6. The coefficient of x is minus 6. And the constant is minus 7. And we're synthetically dividing by 7. Bring the 1 down. 1 times 7 is 7. 7 and minus 6 is 1. 1 times 7 is 7. 7 and minus 6 is 1. 1 times 7 is 7. 7 and minus 7 are 0. So 7 is indeed a root. And the resulting quadratic is x squared plus x plus 1 equals 0. Now you'll find if you try to solve it that the quadratic equation x squared plus x plus 1 equals 0 has no real solutions. So the only possible solution to this cubic is x equals 7. Certain basic identities which you may wish to learn can help in factorizing both cubics and quadratics. I'll just give you one example. We have the equation x cubed plus 3x squared plus 3x plus 1 equals 0. 1, 3, 3, 1 is the standard expansion of x plus 1 cubed. So the solution to this equation is x plus 1 cubed equals 0. We have the root minus 1, x equals minus 1, repeated 3 times. If you can't find a factor by these methods, then draw an accurate graph of the cubic expression. The points where it crosses the x-axis will give you the solutions to the equation, but their accuracy will be limited to the accuracy of your graph. You may indeed find that the graph crosses the x-axis at a point that would suggest a factor. For instance, if you draw a graph that appears to cross the x-axis at, say, x equals a half, then it's worth trying to find out if x minus a half is indeed a factor. Let's look at the equation x cubed plus 4x squared plus x minus 5 equals 0. Now this equation won't yield a factor by any of the methods that I've discussed, so it's time to draw a graph. And this is the graph of y equals x cubed plus 4x squared plus x minus 5. It crosses the x-axis at 3 places, one near x equals minus 3, one near x equals minus 2, and one near x equals 1. Depending on how accurate your graph is, you may be able to pinpoint it a bit closer than this, and we get solutions. X is approximately equal to minus 3.2, minus 1.7, and 0.9. These solutions may be accurate enough for your needs, but if you require more accurate answers, then you should use a numerical algorithm using the approximate answers that you obtained from the graph as a starting point.